what if the key to a more sustainable world, to materials that could replace leather, plastics, and even, build our homes, has been right under our feet all along?
It really sounds like something out of a futuristic novel, doesn't it? But for fungi, it's not fiction.
No, it's not.
It's their ancient role, and honestly, it's rapidly becoming our future.
You've hit on it
Wow.
perfectly. Welcome, everyone, to the Deep Dive. Today, we're plunging into the fascinating world of fungi and their, well, utterly unexpected yet entirely logical role in shaping our material future.
Yeah, it seems unexpected at first, but it makes so much sense when you dig in.
Exactly. So our mission today is to unpack a collection of sources. We've got cutting-edge scientific research papers from places like the Royal College of Art, the Royal Institute of Technology, industry reports, and some really cool design case studies.
And you'll get the surprising facts, the key takeaways on how fungi are, well, revolutionizing everything from fashion to furniture. We're distilling these insights so you get the essential knowledge without, feeling overwhelmed by all the data.
Get ready for some serious aha moments, because we're about to explore how these ancient organisms are becoming the fundamental building blocks for a new, much greener economy.
And as we explore this, a key question keeps popping up, right?
Which is?
How do we actually move past our sort of historical biases, the ick factor sometimes associated with fungi? How do we get people to truly embrace their potential as a material of the future?
That's a huge part of it. Okay, let's dig in.
Right. So to understand fungi's incredible modern potential, we first need to appreciate their deep, ancient past with us. There's a whole field, ethnomycology.
Right, that studies the historical relationship between humans and fungi.
Exactly. And it reveals a truly long-standing connection, centuries, millennia even.
Indeed, and it highlights fungi's crucial role as what one researcher calls interface organisms between life and death, which sounds dramatic, but it's true.
It really is. I mean, think of them as the planet's ultimate recyclers. They break down organic matter, return essential elements like carbon and nitrogen to the soil. They're literally feeding everything else and sustaining planetary biodiversity.
It's fundamental.
Absolutely fundamental. And this recycling power, it forms the basis for some remarkable applications today. Things like mycofiltration.
Using fungi to filter pollutants, right?
Yeah. And mycoforestry for ecological restoration, mycoremediation for cleaning up contaminated sites, even mycopesticides.
Wow.
Some experts even propose these applications as a means for the mycological rescue of the planet. It's quite a statement.
It is, but you can see why. It's remarkable how versatile these organisms are. Let's unpack some of the more surprising ancient uses, maybe beyond just food and medicine, that really showcase their material potential.
Okay.
For instance, indigenous people used the dried fruit bodies of this anise-smelling polypore, Haploporus odorus is the scientific name, as scented body adornment. They believed it enhanced manhood and created a kind of spiritual link.
That's just one example of human ingenuity, isn't it? Historically, fungi weren't just for adornment, though.
No.
Remember ink caps? The shaggy ink cap and common ink cap mushrooms, Coprinus comatus and Coprinus atramentarius.
Oh, right. They were used to manufacture ink.
Exactly.
Yeah.
And have you ever heard of Tunbridge ware?
Tunbridge ware. Sounds familiar.
It's this type of intricate, decorative woodwork. Sometimes it incorporated timber stain, this beautiful blue-green color, by the green elf cup fungus, Corsporia aeruginosations.
That's truly fascinating. And just thinking about pure survival. Various bracket fungi, like the tinder polypore, Fomes fomentarius, and Phalinus ignarius, they were vital for millennia as tinder, just for carrying fire.
Absolutely essential. And people found other ingenious ways to leverage fungi for practical needs, too.
Like what?
Well, fashioning the black, sort of horsehair-like hyphae of Marasmius cornicequi into jewelry strings in places like Congo and Indonesia.
Wow.
Or using the tough rhizomorphs of Polyporus rhizomorphus to make belts in Gabon.
Incredible. These historical uses really demonstrate fungi's inherent material potential, don't they?
They absolutely do. And that leads us directly to a particularly fascinating example. Amadou leather.
Amadou. Okay.
This is a suede-like material derived from that same tinder polypore we just mentioned, Fomes fomentarius.
That's a great tie-in.
Yeah.
So how did they make it?
Well, for hundreds of years, craftsmen in places like Hungary, Bohemia, Romania, they meticulously extracted the inner fleshy part of its fruit body. It's called the fibrous trauma.
Okay.
And they processed it to create these surprisingly durable leather-like sheets.
And I use these for?
Hats, mostly. Other wearable items, too, often sold in local markets.
Amazing.
And what's truly insightful here is how this ancient, pretty low-tech practice.
Yeah.
It really laid the groundwork for modern scientific engineering. Today, we're not just observing, we're actively replicating these complex mycelial structures.
So engineering foams and leather-like materials that can directly replace less sustainable options.
Precisely. It's ancient wisdom informing cutting-edge science. It's quite poetic, really.
It really is. And beyond these structural uses, fungi are also making a vibrant splash in the world of color and paper.
Oh yeah, the dyeing aspect is fascinating.
There's a growing interest in using fungi for dyeing, right? And while it feels very modern, mushroom dyes actually have a long tradition.
They do. Initially used by indigenous cultures, maybe as war paints or early forms of cosmetics, it stems from older lichen dyes like orchil and cudbear.
But the modern movement,
Mm.
that kicked off more recently.
Yeah, it really took off in the 1960s with Miriam Rice in California. Apparently, she just serendipitously discovered that a clump of sulfur tufts gave this brilliant yellow dye.
Wow.
And she went on to pioneer and document this whole global community dedicated to the art.
And here's where it gets truly surprising, I think. Fungi can yield a full spectrum of color, sometimes multiple colors from the same fungus.
That's the amazing part. Take Dermotocybe phoenicia occidentalis, for example. By simply regulating the pH, adding a bit of white vinegar or washing soda, you can get anything from pastel pinks to bright reds, browns, dark purples, all from one batch.
That's incredible flexibility.
It is. Plus, the chitin content in fungal cell walls, that's the tough, fibrous stuff you also find in insect exoskeletons.
Right.
It makes these dyes incredibly wash and color fast. They really stick.
Okay, so they don't just fade out easily.
Exactly. A huge plus. And that very same chitin content also makes fungi excellent for paper making.
Ah, right. So you can make paper from mushrooms too.
You can. High-value, handcrafted paper can be produced from specific bracket fungi, like the birch polypore, Pictoporus botulinus,
Yeah.
the red banda polypore, Fomitopsis pinicola.
And let me guess, Fomes fomentarius.
And yes, our old friend, the tinder polypore again. It's quite the all-rounder.
It really is. What's cool about the paper?
Well, what's really neat is that this paper's high lignin content, that's the natural polymer that gives wood its rigidity.
Yeah.
It means no additional binding agent is needed.
Oh,
So you end up with a wholly natural, wonderfully environmentally friendly paper.
that's fantastic. All these ancient and varied uses, I mean, from clothing to construction to dye to paper, it truly sets the stage for the modern explosion of mycelium in material science.
Absolutely. It shows the inherent potential was always there, just waiting for the right moment.
Which brings us to the last decade or so. We've seen this rapid growth in mycelium-based technologies, and it really feels like a perfect storm.
It does. This rapid progress seems driven by parallel advances in three key areas, really.
Okay, what are they?
First, you have these science-led companies. They're investing massively in developing sustainable alternatives, victimless alternatives to animal or petroleum-based materials.
Right, aligning with the whole bioeconomy idea, circular economy goals.
Exactly. And the UN Global Sustainability Goals, too. There's a strong ethical and environmental drive there.
Okay, that's one. What's the second?
Second, the design community. They've shown this really keen interest in biofabrication.
Biofabrication. Basically, using living organisms to create materials.
Precisely. Designers are collaborating directly with scientists to literally grow products instead of relying on finite resources. People like Suzanne Lee, Nancy Tilbury, Carol Collette, Maurizio Montalti, they've been true pioneers pushing the boundaries.
Okay, science-led companies, the design community, and third.
And third, perhaps most importantly, the emergence of the conscious consumer. These are people who demand quality, but they don't want to compromise planetary health. They're increasingly holding companies accountable for sustainable, transparent, ethical processes.
So this convergence, the science, the design interests, the consumer demand, along with things like open innovation, and just the sheer urgency of the environmental crisis.
Yeah, it created exactly the right conditions for these mycelium-based materials to start getting traction in the market.
It really begs that question again, though.
Yeah.
How do we get everyone to fully embrace this potential? It feels like we're still on the cusp.
We are. But speaking of pioneers, Suzanne Lee's work with biocouture back in the 2000s was truly transformative in shifting
Tell
perceptions.
us about that. She wasn't using fungi initially, was she?
No, she explored growing materials from bacterial cellulose, actually, inspired by the fermentation process used to make kombucha tea.
Kombucha leather. Okay.
Sort of. She'd cultivate this material in large vats until a sufficient sort of leathery layer formed. Then it could be harvested and either molded directly or cut and sewn like conventional fabric.
And how did she make people see the potential?
Well, to make the concept accessible, Lee recreated iconic fashion items, kimonos, court shoes, bomber jackets, using this bacterial cellulose.
Ah, smart. Make it familiar.
Exactly. She used sustainable vegetable dyeing, oxidation, giving them a high street appeal. It demonstrated how these could become sustainable, organic, biocompostable, biodegradable products people could actually imagine wearing.
Bringing it out of the lab visually.
Right. And even before this widespread mycelium movement, there were fascinating fungi-specific design examples, too.
Yeah.
Back in 1997, the Belgian designer Martin Margiela, he famously treated replica garments with bacteria and molds for an exhibition called 941615.
Molds on clothes? That sounds provocative.
It was a critique of fashion's transient nature, highlighting cycles of creation and decay using the organisms themselves.
Wow. And then there was.
Then in 2004, Australian designer Dr. Donna Franklin created this truly living dress, fiber reactive.
Living? How?
It was constructed from the actual mycelium and fruit bodies of the orange bracket fungus Pycnoporus cotineus.
No way.
Yeah. This groundbreaking piece was exhibited in major museums, really pushing the boundaries of what a garment could even be.
These early conceptual pieces seem vital for shifting public perception, challenging those biases we talked about.
Absolutely. Maurizio Montalti's 2010 project, Continuous Bodies, was particularly thought-provoking in that vein.
What did that involve?
He proposed a mycelium shroud for sustainable human body decomposition. The idea was the fungi would transform bodily toxins into useful soil compounds. Yeah. Powerfully embodying that idea of fungi as interface organisms between life and death, not just in nature, but in our design thinking, too. It forces you to reconsider decay.
That truly redefines our perception of decay and renewal. And then there's Phil Ross's mycotexture from around 2008.
Right, working out of San Francisco, he was growing strong, lightweight structures from reishi mushrooms.
Reishi, like the medicinal mushroom.
The very same. Growing them into building blocks, molded domestic objects like chairs. His work really showcased fungi as an innovative, sustainable material with real architectural potential.
So these early explorations, they really paved the way for mycelium to enter the commercial marketplace, didn't they? Moving from lab concepts to lifestyle products.
Exactly, which leads us to some of the key commercial players.
Like Ecovative, founded back in 2007 by Eben Baer and Gavin McIntyre.
Yeah, Ecovative. They specialize in mycelium bonding technology, basically transforming agricultural byproducts, waste streams,
Right.
into composites. Their mycocomposite TM is used for sustainable packaging, insulation, even building blocks.
Taking waste and binding it with mycelium.
Clever. Very. Then there's MycoWorks, founded in 2013 by Phil Ross, again, and Sophia Wang.
Okay, what's their angle?
They refined Ross's original mycotexture into their patented fine mycelium technology. This lets them engineer dense, interlocking mycelial structures.
For what kinds of products?
Panels, molded forms, and flexible leather-like materials like their Reishi TM brand. And crucially, they focus on engineering the desired strength, performance, aesthetic during the growth process.
So not just compressing it afterwards, but controlling the structure as it forms.
Exactly. Aiming for those high-quality standards needed for fashion and footwear, which can be different from just, say, packaging foam.
Makes sense. And we can't forget Bolt Threads, founded 2009 by bioengineers, biochemists, a real science-heavy team.
Right. They launched Milo TM in 2018, another mycelium-based leather alternative.
And they had some big fashion collaborations, didn't they?
They did. Stella McCartney recreated her iconic Falabella bag using Milo TM that was showcased at the V&A Museum in London. And there was that fashion consortium, Stella McCartney again, Adidas, Lululemon, Kering. They launched the Stan Smith Milo TM shoe.
That feels like a big step into the mainstream.
It was. And that collaboration involved the whole chain. Mushroom growers in the Netherlands using vertical farming, European tanneries for the finishing touches, and the fashion and sportswear industries scaling it to market.
A whole ecosystem approach.
Yeah. However, there's been a recent development.
Oh,
Bolt Threads has actually paused MyloTM production indefinitely. They cited challenges in the current economic climate for securing capital.
oh, that's disappointing.
Mhm.
Does that signal a problem for the whole field?
Well, it's certainly a setback for MyloTM specifically, and maybe a reality check on the challenges of scaling these new techs, but it doesn't signify the end for the industry as a whole.
Okay.
Other startups like MycoWorks and Ecovative are still actively working on their materials, and the broader industry continues to explore other plant-based alternatives to pineapple, cactus, coconut.
Right, it's not just fungi.
Exactly. The journey to scalable, sustainable materials is complex. There will be bumps, different players, different paths. MyloTM's pause is part of that story, not the end of it.
That's a crucial point about the resilience of the overall movement.
Hmm.
Okay, shifting back to Europe for a moment. Maurizio Montalti, who we mentioned earlier, he's had continued influence, right?
Absolutely. He's been leading the introduction of fungi-based materials through his consultancy, Officina Corpuscoli, founded in 2010.
And his process.
Yeah.
You mentioned growing design.
Yeah, he describes it as being like slow 3D printing, cultivating objects from local waste, or even biodegrading polymers to replace harmful plastics.
Very cool. Any standout projects?
Definitely. The Future of Plastic exhibition back in 2014 was impactful, and the MoMA commission for the Mars boot prototype in 2017-18 with Liz Chicaglo.
Mars boot.
Yeah. Exploring material culture evolution for new worlds, combining high-tech and low-tech approaches, really forward-thinking stuff.
It sounds like it. And building on that consultancy work.
He also co-founded Mogu in 2015. The aim there was really to standardize and scale mycelium technology for commercial applications.
So moving beyond prototypes.
Exactly, producing composites and pure mycelium materials for things like flooring, acoustic interior panels, fashion, furniture, all following circular economy principles.
And the properties are good.
Yeah, typically light, low density, but strong and shock absorbing. Good acoustic properties, too.
Okay. And mycelium is even meeting advanced manufacturing, like 3D printing.
It is. Eric Clanenbeek is a pioneer there. What he did was adapt a 3D printer to print straw that was injected with mycelium. This created strong, solid, lightweight structures, but with really intricate detail possible through the printing.
Wow, 3D printing with living material, essentially.
Kind of, yeah. He later improved the tech using algae and seaweed-based biopolymers, which led to this fully bio-based installation called the Growing Pavilion in 2019.
These advancements, they seem to have fundamentally shifted the design conversation, haven't they?
They really have. It's moved from what if to focusing on practicalities, consumer engagement, aesthetic properties, performance, and creating this holistic narrative around the material, its application, and its sustainability.
Which perfectly tees up the next crucial piece, the sustainability factor itself.
Yeah.
We need the data, right?
Exactly. To truly understand the environmental promise of mycelium, we need to turn to life cycle assessments, or LCAs.
So just quickly, remind us what an LCA is.
Sure. It's basically a systematic tool. It evaluates the potential environmental impacts of a product across its life cycle, often cradle to gate, which means
Raw material extraction all the way to the finished product leaving the factory gate.
precisely. It's crucial for identifying environmental hotspots, areas for improvement, and helping make sustainable decisions.
And we're looking at a specific LCA study here.
Yes, one that compared bovine leather, polyurethane or PU leather, and mycelium leather, specifically focusing on headphone ear pads, an interesting common application.
Okay, let's break down the results. What did they find for traditional bovine leather?
Unsurprisingly, perhaps, bovine leather consistently showed the highest environmental impact across most categories.
Like carbon footprint.
Huge carbon footprint, estimated at 21.0 kilograms of CO2 equivalent per square meter. Now, to put that in perspective, that's roughly like driving a standard gasoline car for about 50 miles or 80 kilometers.
Wow, per square meter of leather. Where does that mostly come from?
Farming. A massive 61% of this footprint comes from the agricultural side, raising the cattle. Tanning adds another significant chunk, about 11%.
And it gets more striking when you look at toxicity.
Right, absolutely. Bovine leather showed the highest toxicity potential. For non-carcinogenic human toxicity, it was extraordinarily high. 139.3 kilograms of 1,4-DCB equivalent.
Okay, 1,4-DCB. That's a benchmark chemical for toxicity.
It is. So that number signifies an immense potential for harm, almost entirely due to agricultural practices, think manure management, pesticide use.
And tanning.
Tanning processes were the primary cause of ecotoxicity and carcinogenic human toxicity, plus high water consumption too, estimated at 0.19 cubic meters per square meter.
That's like a small bathtub full of water per square meter of leather.
Pretty much. And a lot of that is linked to growing animal feed. So, the conclusion. Despite its durability, for products with shorter lifespans like headphone ear pads, its overall environmental burden makes it a pretty unsustainable choice.
Okay. What about the common alternative, PU leather?
Right, polyurethane or PU leather. Generally, it had a lower impact than bovine leather, but still presented significant concerns.
Mainly because?
Its reliance on fossil fuels, that was its biggest contribution factor. It had the highest fossil fuel potential among the three materials at 2.8 kilograms of oil equivalent.
In energy use.
Production is also energy intensive. Electricity use was a notable contributor, leading to a carbon footprint of 9.0 kilograms of CO2 equivalent, still significant, though less than half of bovine leather.
Plus, there are other issues with PU, right? Like chemicals and end of life.
Exactly. Concerns about chemical pollution during manufacturing and its non-biodegradability remain, even with newer waterborne production methods. It's still plastic, essentially.
Okay, and finally, the star of our show, mycelium leather. How did it fare?
It had the lowest environmental impact in all categories assessed.
All of them. Wow. Carbon footprint.
Estimated at just 2.4 kilograms of CO2 equivalent. Compare that to 21 for bovine leather or 9 for PU.
It's a massive difference. And fossil fuel use.
Also very low. Just zero point 0.4 kilograms of oil equivalent compared to 2.8 for PU.
So why is it so much better? What are the key advantages?
It really stems from two main things in the LCA's assumptions. First, that the mycelium is cultivated using agricultural or industrial waste products as its food source, its substrate.
Right, so that circular economy aspect dramatically alleviates the environmental burden.
Exactly, you're turning waste into value. Second, the cultivation process itself is generally low energy compared to raising cattle or synthesizing polymers.
But there must be some impact. Where does it come from?
Electricity usage still remains a major contributor, relatively speaking, for mycelium leather, which indicates that the choice of energy source for large-scale production renewables versus fossil fuels will be absolutely crucial for its overall environmental impact moving forward.
That makes sense. But looking at these numbers side by side, the insight isn't just that mycelium wins, is it?
No, I think the striking insight is how much the very foundational source of a material dictates its burden, whether it's livestock, fossil fuels, or repurposed waste. That initial choice seems more critical than almost anything else.
It really pushes us to rethink materials from the ground up, literally.
It does.
Okay, so the environmental case looks strong.
Yeah.
But how does mycelium leather actually stack up as an ear pad material? Thinking about practical properties, durability, comfort, sound isolation.
Good question. The study looked into this. Its tensile strength, how much you can pull it before it breaks, is actually comparable to PU leather, meeting the basic requirements for ear pads.
Okay, that's promising. Any weaknesses?
Well, its tear strength resistance to ripping might currently lack potential, as the study put it. So that's an area for ongoing development.
And what about things like water? Mycelium seems like it would just soak it up.
It is naturally absorbent, yeah. But the material can be tailored with coatings and treatments. Things like glycerol or hydrophobic bio-based binders can significantly increase its water repellence for real-world use.
So it can be engineered for performance. What about acoustics? That's key for headphones.
Actually, its acoustic properties show great promise. The study mentioned that 25-millimeter thick mycelium panels, thicker than an ear pad, obviously, but indicative, can achieve up to 70–75% acoustic absorption at 1,000 hertz.
Which suggests good sound isolation potential for ear pads.
Exactly.
So it's clear there's massive potential here. Mycelium leather might still be in sort of an experimental phase in some ways.
Yeah, maybe not yet fully meeting all the performance standards of traditional PU leather across the board.
But it's becoming increasingly durable and applicable. And the study emphasizes, quite rightly, that thorough evaluation of prototypes is crucial.
Absolutely. Because a material isn't truly sustainable if it just falls apart, right? That would undermine the whole point. Durability matters.
Definitely. So despite all these advancements and the compelling data, there are still significant challenges to overcome, particularly around public perception and adoption.
Oh yeah, the mold problem, as we sometimes call it. That's a big one.
It's funny how deeply ingrained these aversions are, isn't it? Fungi's popular association with mold, decay. It often triggers this visceral disease avoidance behavior, disgust, a sense of impurity.
It's primal almost, influenced by the visual and olfactory stimuli of decay.
I remember seeing a piece of art once completely covered in what looked like carefully cultivated mold, and my initial reaction was still this gut-level ew, even though I intellectually knew it was intentional art. How do we truly bridge that gap for everyday consumers?
It's a profound psychological hurdle. There was an interesting project that trying to address this directly. Ivanova's Molded Mind Masters project from 2011.
What did she do?
She explored using macrophotography of microscopic molds, finding the beauty in them to inspire garment collection. The goal was precisely to overcome these negative associations, educate the public on fungi's value.
Did it work?
She even included living garments with encapsulated molds to provoke engagement. But, as the source notes, there are still clear challenges with consumer acceptance for high street brands when you present mold that directly. It's a tough sell.
Yeah, I can imagine. This reminds me of lessons we can learn from history, actually.
Yeah.
Specifically, the story of nylon.
Ah, the artificial silk analogy, yes.
Exactly. Back in the early 1900s, materials like viscose rayon were introduced. Then nylon in the 1930s, often marketed that way. But getting people to accept them wasn't easy, was it?
Not at all. The market assimilation process was lengthy and challenging. There was initial negative public perception terms like artificiality, counterfeiting of the authentic were common.
And the early versions were always great quality either.
No, the early synthetics often had less than ideal tactile and visual qualities. It took significant branding and promotion slogans like DuPont's Better Things for Better Living to convince consumers of their quality and luxury to make them feel comparable to silk.
It truly took decades, didn't it? And
Yeah.
the work of innovative fashion designers to really explore and develop the potential of synthetics.
Absolutely. And even today, you could argue a suspicion, if not a prejudice, against the words plastic and synthetic still lingers in our collective psyche for some people.
So what does this all mean for mycelium? What's the lesson here?
I think it highlights that a more holistic, stakeholder-inclusive approach is crucial. It needs design, science, and engineering working together, considering all the human, material, and sensory factors right from the start.
To hopefully achieve a faster, more fluent integration than synthetics had. It's not just about the science, it's about the story, the feel, the perception.
Precisely. It's about the entire experience.
Which brings us to a fantastic case study in exactly that human engagement and overcoming those perception hurdles. The mycelium plus timber collaboration?
Yes. Started in 2016 between Ninella Ivanova and Sebastian Cox Ltd., the furniture design company.
What was their goal there?
Their purpose was directly inspired by seeing how fungi naturally bind things together in the forest, like tree branches. The goal was to use mycelium as a natural alternative to synthetic glues and engineered wood products.
In using waste wood?
Exactly. Utilizing wood chip waste and low economic value timber like coppiced hazel and goat willow stuff that often just goes to waste. A brilliant example of circularity again.
So what was their process?
They identified fomentarius, yes, the tinder polypore again,
Right.
as a suitable species. They'd grow it on sterilized wood waste,
Okay.
mold it into the desired shapes for furniture parts, and then gently kiln dry it to terminate the fungal growth, locking the shape.
And it's low energy.
Crucially, yes, a very low energy process. No extreme temperature, humidity, or special light requirements needed for the growth phase.
What properties did they observe in the final material?
Remarkable stuff. Changes in color and texture as it grew, the mycelium's ability to perfectly take the mold shape, its amazing binding properties creating seamless joins between wood pieces.
Wow.
Its lightness, a slightly spongy texture that could be good for cushioning or insulation, a pleasant woody and earthy smell, not moldy, and a soft velvety texture.
Velvety. That's not what you expect.
Right. It also proved to be naturally hydrophobic, water repellent, and fire retardant. Lots of inherent benefits.
So what did they make?
The initial outcomes were prototypes of ceiling tendons and stools designed to beautifully integrate the fungus in the wood, visually showing the bond.
But the presentation was key, you said.
Absolutely key. They carefully introduced the collection at London Design Festival in 2017.
Yeah.
And crucially, they displayed it in a thoughtfully arranged domestic setting at Somerset House, not a sterile white gallery space.
Making it feel like home furnishings from the start.
Exactly. And visitors were actively encouraged to touch the objects, feel that velvety texture, even smell them.
Getting over the fear through sensory engagement.
Precisely. Plus, the transparency of the production process, they had objects literally growing during the exhibition, really captured the audience's imagination. It wasn't just showing a finished product, it was sharing the fascinating process.
So this direct sensory engagement combined with that holistic narrative, the material choice, the design process, the aesthetic, the function.
It successfully worked to normalize these fungi-derived products. It took them out of the lab or the gallery space, as the researchers put it, and into a collective appreciation of their value and applications within the home.
It's about making the unfamiliar familiar and desirable. That seems crucial for widespread adoption.
Couldn't agree more.
So, wrapping things up, we've explored fungi's ancient roots, their current material revolution, the compelling sustainability data that backs them up, and these incredibly creative ways designers are tackling that crucial human element of perception.
Yeah, the story of fungi in design is definitely still unfolding. We're seeing that move from speculative prototypes towards commercially viable products. It's constantly pushing boundaries and I think evolving our relationship with the natural world itself.
It really is, which raises an important final thought, maybe. If we can grow our materials from the ground up,
Yeah.
literally, with low energy and less waste, how might our everyday objects become active participants in natural cycles? Nurturing the environment even after we're done with them.
And what unexpected new sensory experiences might this bring into our homes and lives? The feel, the smell, the look of these living derived materials.
Something for all of you to mull over until our next deep dive.